Hi everybody, this video is part of the ethical hacking course. I will be demonstrating a very popular and a very powerful tool called Wireshark. Wireshark is basically a network packet analyzer. And what this means is that using Wireshark, we will be able to capture network traffic and see what's inside the packets. Wireshark allows us to do deep packet inspection. It supports multiple platforms, so you can install it directly on your machine, on your Windows machine, for example, but it is available inside our Kali. Okay, so I will be demonstrating this tool for two reasons. One is that it directly relates to our Lab 3 activity, but also I want you to see these packets, the data, the headers that I talked about in the networking fundamentals chapter. I am recording from class, so it is a little bit noisy, and I hope the audio quality is acceptable. All right, so my Kali is up and running, and my two targets are up and running. And as always, I like to start by getting the IP address, including the network address, which is class C, if you remember, /24. I will keep it in my clipboard. I will run a quick host discovery scan using Nmap. Basically, I'll be scanning the network. I should be able to discover the two target along with other virtual adapters like the DNS server, the DHCP server, and so on. So I have the information, my IP address, it's important to note it because we will see all these addresses in our tool. Mine is 128. I have the .1, the .2. You notice here, .2 has a running service on port 53. If you remember, port 53 is the DNS port. Also, I have my two target, .129 and .130. Okay, so just before I start up the tool, I just want to highlight important things that I discussed in the chapter. So let's go just for a few minutes to the slides. If you remember, the TCP/IP protocol is a stack of protocol. The two important characteristics for a stack in computing is that the lower layers are needed to support the layers on top of them. So in this diagram right here, the network layer, which is the lowest layer, is needed to provide support for the internet layer. The transport layer will need the two layers below it, and the application layer will need the three layers below it. Another important characteristic of a stack is that when we use it, we usually start from the top. So in our case, how we use this stack is to start communicating, right? So two computers communicating with each other. So let's use an example of me, let's say, accessing a website. So the data is at the application layer. I use a program or an application called the web browser. It's a client application, and my data is basically my request for the home page of some website, let's say google.com. So this is the data. Wireshark will allow us to see this data. As the data flows downward, I will add some header information at the transport layer. And if you remember here, I should be able to see one of two protocols, the TCP or the UDP. Each one of them has header information like port for the source and the destination, sequence numbers, flags, and so on. Again, in Wireshark, we will be able to see the header information. And as the data flows downward to the internet layer, this is the addressing layer. This is the layer that takes care of the logical addresses, the routing, etc. So in this layer, I will be able to see the IP header, which among other things will include the IP address. So again, the source and the destination addresses will be visible for us when we look at them in Wireshark. And finally, the network layer is where I have the physical connection, be it wired or wireless. So you'll be able to see the Ethernet protocol on this layer. And basically, among other things, you will see the physical address of the computers. Again, the source and the destination, which is the MAC address. Having said that, we are ready to go and explore our tool. So let's go back to Kali Linux, and these are the tools that I talked about in the beginning, if you remember. And we said really hundreds of tools are available in Kali, and they are organized by the security function or activity that we do. Wireshark, because it's a network packet analyzer, it is classified as a sniffing tool. So basically, I can find it here. As soon as you launch Wireshark, you will be able to see that it allows you to capture traffic from different network interfaces that you might have. Just as a reminder, when we ran the IPA command, we saw two groups. We saw the F0 and we saw also, if you remember, the LO or the loopback. So F0 is my Ethernet interface, my main interface basically, and I'm ready to capture traffic using this interface. So the first thing I want my students to do when they use a new tool is always to be familiar with the interface. Now, this is a very powerful tool and it's intuitive. It has a 3-pane structure, which is a standard structure for these kind of tools. And you will see these 3 panes shortly. But also it has very powerful filtering. And this is what I want my students to be able to use these filters as they need. So this is the shark fin to start the capture. We will go ahead and start it. Now let's see, this is one of the panes. This is where you will see the list of packets. But of course, as of now, I have nothing. So I will go to my command terminal here and I will run a command. Let's say I'm gonna ping one of my machines. Oops, let me ping. And let's ping Google actually, since it's already there. You can ping. And as you see, as soon as the ping starts, you can see here something is happening in Wireshark. Okay, it's capturing the network traffic flowing out of my machine, out of my Kali, and into my machine. But we will see the details in a bit. I'm going to stop this. As you can see here, if we go back to that terminal window, I sent 25 packets transmitted, 0 received, 100% lost. So I didn't receive anything, and I should be able to see all of that in Wireshark. It is still capturing. This is a live capture mode. So I'm going to ping one of my targets. So 192.168.130 or 129. Doesn't matter really. You see that it is transmitting and receiving back. So again, notice that Wireshark is capturing all the traffic. Again, I will stop it. Okay. Now let's go back to Nmap, and I know I didn't discuss what's going to happen next, but let me show you something very interesting. So here in this target, in the .129 target, I noticed that Telnet is open. This Telnet service, if you recall, it's a remote connection service. It allows us to remotely connect to a machine or a host. So this machine, one of my target, has telnet open. But if you also remember, telnet is a clear text protocol. That means it's if there is a username and password, they will be in clear text. They will not be encrypted. So this is very interesting because Wireshark not only allows you to see the header data, but it allows you to see the actual data in your packet, including username and password. And if they're in clear text, well, this is even better. So let's go ahead and telnet to this target. .182. Okay, and you see again that Wireshark is doing its thing. It's asking me for login, which I don't know really. I'm gonna just say admin, and the password is, let's call it also admin or use password, whatever. It doesn't matter. I just want to show you that I will be able to see this information in Wireshark because I've captured it. Okay, so at this point, I am ready to stop the live capture. Okay, and what I want to do is show you again this Wireshark interface. I talked about a three-pane user interface. The upper pane has the packet, and as you see, I captured 159 packets in just running 2 pings and a telnet command. Of course, sometimes you capture thousands and thousands of packets, and sometimes you will be given a network traffic file, for example, a PCAP file, and you will open it and you will see 10,000 packets or more. So remember, filtering is a very important feature and very useful feature in Wireshark, and you should get familiar with it. So this is the list of packets. When you choose a packet, in the second pane, the middle one, you will be able to see the packet details. And finally, when you go to the packet details and look at the lower pane, you will be able to see some byte information. So just I'm gonna choose one of the telnet packets. Let me, before I choose, let me show you some of the filtering features. So remember, I ran 2 ping commands and 1 telnet. Ping, if you remember, is ICMP protocol, and if you type it correctly, it will give you green here, indicating that this is a valid filter that you can use. So I'm gonna go ahead and either hit enter or click this arrow, and I have nothing but ICMP. Okay, to clear the filter, you click here the X. Let me go now to telnet. I'm gonna filter by telnet. I mistyped it, and as you can see, it was in red. Again, let me filter by telnet. So I'm gonna choose one of the telnet packets, and I'm gonna right click on it. I will go to follow TCP stream, and take a look here, the login information, the password, I can see it in clear text. So if this is an actual password and you managed to capture this traffic while you were performing, let's say, sniffing, then you will be able to see clear text username and password. Okay, so let's start with any random packet from here. Let me show you a few important information. So this is the number. So it's a sequence, 116, 17, 18, and so on. Then you will see the time, okay? And then after that, the source of the packet. So this one that I'm highlighting is from 129 back to me. Remember, I am Cali, I am 128. This one packet number 118, is from me to the source, to the target, sorry. This is sometimes confusing because some students tend to think that I am always the source or I am always the destination. No, remember, it's communication. If I'm talking to you, I am the source, you're the destination. If I'm listening to you, you're the source, I am the destination. So when you select the packet, you need to see who's the source, who is the destination. Next is the protocol. So you will see Telnet, TCP, then you can see some additional information. Again, we will get to see all of those in details where in the middle pane right here. So if I select, for example, the Telnet packet, right, this one, you will see down here I have the frame, the Ethernet. Both of those together are in our TCP IP stack. They're combined into the network layer. This is the physical connection layer. And in here, I should be able to see the Ethernet protocol. I also should be able to see the MAC addresses. And here they are. Actually, you can see them. So the destination MAC address, the source MAC address. So notice the packet that is selected, number 119, I am the source. It's from 128, from Cali to my target. So this is my MAC address. This is my target's MAC address. Okay. Next, after these two, the third one, remember the layers. At the bottom, you have the internet, the network. Then on top of it, you have the internet. This is where I should be able to see the source and destination IP addresses. So the source address, again, you can see it here, and the DST is destination. So SRC is source, DST is destination. Next, before I move next, if you're running ICMP, you should be able to see additional interesting information, because if you remember, when we ping, we're sending ICMP echo requests, and if the computer, the target computer, responds, then I will see echo reply. We will see that very shortly. On top of the internet layer, you have the transport layer. Here, I should be able to see either TCP, Transmission Control Protocol, or UDP. In this case, it is TCP. So this is a common question. I ask my student to look at a packet and analyze it and give me information about it. So this is where you're getting the information. Again, the source port is 53188. What is this port? Remember, computers have 65,536 ports. The first 1,000 somethings are reserved, then there are some for vendors, and then there are some dynamic port numbers that I use whenever I need. This is one of them. Because it's going from my machine, I'm using this dynamic random port. The destination port is not dynamic, is not random. It is 23. This is the telnet port. Okay? And of course, the last part here is the actual application layer protocol. In this case, is telnet. So if I'm using the web, if I open my web browser and capture the traffic, this will be HTTP. If I am managing some network devices, it might be SNMP. If I am sending email, you may see IMAP or SMTP. So at this layer, okay? Now let me take another packet. This is a TCP packet. That means in it, there is no application. There is nothing after the TCP, okay? So let me remove the filter and filter again by ICMP and choose ICMP is an internet layer protocol. So in this packet, I don't even see any TCP or UDP or transport layer stuff. So let's see. Okay, frame and Ethernet, my network layer with the MAC addresses, internet protocol, IP protocol with my IP addresses, and then ICMP. I don't see TCP, I don't see UDP. That means in this packet, there is no transport layer. Again, to remind you, in a stack, you may have the lower, okay? You may have the internet and the lower, the network. You may have the transport and then what's below it and so on. So you need the foundation. You can have the foundation, the lower layer, without the upper layers on top of them. And this is exactly what we have in this case. We simply have up to the internet layer, nothing else, no transport, no application. So let me just expand the ICMP part here. And I want to show you just few information. You can expand, you can collapse as you like. Let's take a look at the data, the actual data that I sent in a ping. This is my ping, right? So you can see I sent 48 bytes of data in my ICMP. Okay? So notice also here on top, it is type 8. We will see these type. It's an echo request. Okay? If I choose, so this is me, packet number 56. This is me, Cali, 128, sending to 129. If I go to 129, sending to me, take a look. This is an echo reply. This is the target replying to me. This is it for this video. I expect you to be able to do lab activity number 3.